Very good morning to all our present here. Today is the day we begin to learn to look through the eyes of others, to find out and experience what the world is like today. On behalf of SA Engineering College Management, Principal and faculty members of the Electrical and Electronics Engineering Department, I extend a warm welcome to each and everyone gathered here for the inaugural ceremony of 6 days faculty development program on modernizing next-gen charging infrastructure for electric vehicle, AI-powered management systems and their challenges. SA Engineering College, an autonomous institution, affiliated to Anna University, Institute of Research Center, offers students an advantageous atmosphere with state-of-the-art facilities, distinguished mentors and a pleasant education environment. The institution provides the employability and communication skills for the development of students. It provides quality education in an environment of discipline. It focuses on shaping students to become self-disciplined, self-dependent, and self-confident individuals. SAEC pursues all these steps to move the students' career in such a way that they excel in all kinds of distinctions of life. The college stand is not only on mere acquisition of course knowledge and its application, but also on all-round personality development of the student and his value system. The infrastructure facilities have also been made to allow detailed learning ambience for the students. The full-fledged eco-friendly offers a quality environment to the students. With 26 years of experience in the field of education, the college has 11 UG programs and 6 PG programs, including MBA and MCA, including HNDs. Altogether, we have 18 departments. The Department of Electrical and Electronics Engineering was established in the year of 2001 and got permanent affiliation with the University in 2013. The postgraduate program, ME Embedded System Technologies, was established in the year of 2006. The department has dedicated and well-experienced faculty members. The department has well-equipped laboratories with completed timely by providing adequate opportunity for students to learn and innovate. Our department promotes the professional skills of students in societies like Indian Society for Technical Education, ISTE, and Indian Institute of Electrical and Electronics Engineers, ITP. Career guidance program and entrepreneurship awareness program are also carried out through the Association of the People. Today marks the beginning of a transformative learning journey, a week dedicated to knowledge enhancement, skill development and intellectual exchange in the cutting edge domain of initiative. Your presence truly enriches this event and we are delighted to have you all with us. As we gather today at the threshold of knowledge and discovery, let us begin this day with a moment of praise. I request everyone to raise for the praise song Shamukai Varta, invoking the blessings of the Almighty for wisdom, clarity and harmony.
நீராடும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராடும் மதனமென திகழ்பரதர் கண்டனிதில் தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை முதலும் தைத்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Signify the beginning of any event or occasion, symbolizing knowledge, only ignorance or slight remove darkness. Following in line with tradition, I now request that dignitaries on the dais to light the Kutuvilakku with a prayer to lead us from ignorance to knowledge.
Jangan lagi tali poster. Jangan tali poster. Jangan tali poster. Mana? Ini dengan mana? Nama masuk. Awal itu mana?
Thank you, sir.
Kamu pun kartu.
Gracious welcome sets the tone for every significant beginning, and today is indeed a momentous one. To extend a heartfelt and dignified welcome to this august gathering, I wholeheartedly invite the respected head of the Department, Electrical and Electronics Engineering, Dr. S. Sendar Kumar, to deliver the welcome address.
Very good morning, honorable presented here. With the blessings of Almighty and our founder chairman, Thiru D. Sudarsanam sir, with the support of our board of trustees, our chairman Thiru D. Duraiswamy sir, vice chairman Thiru D. Parandaman sir, the secretary Thiru Dasrathan sir, the correspondent Thiru S. Amarnath sir, joint secretary Thiru S. Gopinath sir, director Sudarsanam Vidyasaram Tirumadi D. Saraswati madam, director SA College of Arts and Science Dr. S. Arvind sir, Director SA Engineering College Thiru D. Sabarinath sir, Correspondent SA College of Arts and Science and Sudarsanam Vidyasaram Thiru P. Venkatesh Raja sir. It gives me immense pleasure to wholeheartedly welcome and thank our distinguished chief guest Dr. Mala K. Welcome madam. A lead engineer from Agenda Limited Chennai for accepting our invite. I also extend my warm welcome to our esteemed principal sir, advisor sir, head of the various department, professor, faculty members, participants from various engineering colleges and my dear students. It's my privilege and honor as head of the Department of Electrical Electronics Engineering to extend a warm and heartfelt welcome to each one of you to the inaugural function of the ATAL Faculty Development Program on modernizing next-gen charging infrastructure for electric vehicle, AI-powered battery management system and their challenges. This 6-day FTP scheduled from 15th to 28th December 2025 marks an important initiative towards strengthening the academic and industry linkages in the fast-growing demand of electric mobility. We are privileged to have with this distinguished experts from various leading industries and premier institutions and advanced research organizations who willing sharing their experience and expertise toward this FDP. The sessions includes ranging from EV architecture and dynamic fast charging, DMS modeling, wireless charging, PV wind, hybrid charging system, and V2G power transfer and energy storage technologies, which promise to offer deep technical insights and practical knowledge. The SA Engineering College is established by Dharmawadi Educational and Charitable Trust in the academic year 1998 to 99. The campus is spread over a vast area of about 42 acres and has 4 lakh square feet of constructed area. The institution has MBA accredited with the 6 departments and a NAC A grade certification. The college offers 11 undergraduate courses in engineering and 4 postgraduate courses in engineering, which includes MBA and MCA. Principal sir, your leadership is pivotal in steering our academic endeavor and we are honored to your presence and your guidance. Advisors sir, your guidance and supports will give spirit and energy. We are honored by your presence sir. Welcome sir. The faculty members, your commitment to education forms the backbone of our academic community. I congratulate the coordinator Dr. S. Kamalakkannan, Professor in the Department of EEE, and the co-coordinator Dr. R. Madana, Assistant Professor, Department of EEE, who got the sanction for the fund to organize this event. Once again, I wholeheartedly welcome you all and wish you a productive and insightful FDP. Thank you all.
Thank you sir for the gracious, warm and inspiring welcome. To offer us a deeper understanding of ATAL's mission, vision and impact, I am delighted to invite Professor Dr. S. Kamalakkannan to present the overview of the ATAL FDP.
Present the overview of the AICTE ATAL Faculty Development Program on Modernizing Next-Gen Charging Infrastructure for Electric Vehicles, AI-Powered Management Systems and Their Challenges, organized by SA Engineering College, Chennai 77, Autonomous Institute-Level Research Center affiliated to Anna University. This FDP is scheduled from 15th to 20th December 2025. Under the esteemed ATAL Academy initiative of AICTE, this 6-day program has been designed to enhance the knowledge and research capability of faculty members in one of the fastest growing technological domains, electric vehicle charging ecosystem integrated with the artificial intelligence. The program aims to provide participants with a comprehensive understanding of next generation EV charging infrastructure, smart energy management, charging optimization, grid integration, cybersecurity challenges, and AI-enabled predictive analytics. Hands-on demonstrations, case studies, and expert interactions will help bridge the gap between theoretical understanding and real-world implementation challenges. We have planned a series of technical sessions delivered by eminent academicians, industry experts, and researchers actively working in EV infrastructure, smart grids, and AI-based systems. Participants will also engage in ATAL mandated activities including article summary, reflective journal writing, assessments and interactive discussions to ensure active and outcome-based learning. This FDP has received an enthusiastic response with 50 participants shortlisted from various institutions across the state. We are confident that this program will create valuable academic insights, foster collaborative research ideas, and support the development of a skilled faculty capable of contributing to India's EV ecosystem and sustainable mobility goals. We extend our sincere gratitude to AICTE ATAL Academy for their continuous support, to all our distinguished resource persons for accepting our invitation, and to the management of SA Engineering College for providing all necessary facilities. We look forward to a productive and enriching FDP. கற்றது கைமண் அளவு, கல்லாதது உலகளவு. கற்பதும் கற்றுக் கொடுப்பதுமே உலகளவு. கற்போம், கற்பிப்போம். நன்றி, வணக்கம்.
We always have a culture of welcoming our distinguished guests by giving them a memento as a token of remembrance, such that it could be an unforgettable day. Now, I request Dr. S. Bhuvaneshwari to come forward and present the chief guest, Dr. K. Mala, with a
ரொம்ப
small
தூக்கிட்டு
token
இருக்கடா
of love.
ரொம்ப தூக்குதா
Thank you, ma'am. Now I request our department HOD, Dr. S. Sendal Kumar, to honor our beloved advisor, Dr. S. Salavanan sir, with a small token of love. Thank you, sir. The strength of any academic endeavor resides in the vision of its leadership. We are truly privileged to be guided by our advisor, whose commitment to excellence continues to elevate this institution. With immense respect, I invite our beloved advisor, Dr. S. Salavanan, to deliver the inaugural address and formally declare the opening of the 6 days ATAL FD.
Distinguished Chief Guest of the Day, Dr. K. Mala, Lead Engineer, Mahindra Research Lady, Mahindra and Mahindra Limited, Chennai, the most respected Board of Trustees, HODs, Organizing Committee members, faculty, invited speakers, and my dear participants. Good morning to one and all present here. It gives me immense pleasure to stand before this distinguished gathering of faculty members and young researchers as we inaugurate this faculty development program organized by the Department of Electrical and Electronics Engineering in association with ATAL, that is AICTE, on modernizing next generation charging infrastructure for electric vehicles, AI powered battery management systems and their challenges. I extend a warm and heartfelt welcome to each of you. Today, we are at a turning point in the history of mobility. The global transition towards electric vehicles is no longer a distinct ambition. It is an urgent necessity driven by our collective commitment to sustainability, energy efficiency, and cleaner futures for generations to come. In this journey, the role of innovative charging technologies and intelligent battery management systems is absolutely pivotal. Artificial intelligence has emerged as a transformative force across all domains, and its integration into battery management systems marks a revolutionary shift. AI-powered BMS not only enhances safety, performance, and battery lifespan, but also enables predictive maintenance, optimized charging cycles, smart grid responsiveness, data-driven decision making. These are the building blocks of a future-ready EV ecosystem. However, with the innovation comes a new set of challenges: technical, operational, regulatory, environmental, and ethical. Understanding issues related to thermal management, cyber security, interoperability, fast charging infrastructure, and material sustainability requires deep academic inquiry and collaborative research. This is where the role of faculty becomes truly vital. This faculty development program is not merely an academic event. It is a platform for intellectual exchange, interdisciplinary learning and capacity building. Over the next sessions, you will have the opportunity to engage with the experts who are shaping the global UV landscape. I encourage each participant to observe, question, collaborate and contribute. Let these discussions inspire new ideas, research proposals and innovations that can influence policies and transform industry practices. The responsibility of shaping the next generation of engineers rests with you. By understanding the latest advancements and challenges in EV technology, you empower your students to become innovators, solution architects and responsible technologists capable of shaping India's clean mobility vision. As we commence this program, let us reaffirm our commitment to advancing knowledge, fostering innovation and building a sustainable technological future. Together, let us ignite curiosity, encourage creativity and drive meaningful transformation in the field of electric mobility. I wish this faculty development program great success and look forward to the impactful discussions and outcomes it will generate. Thank you, and I once again extend my warmest wishes to all the participants. Let this journey towards modernizing next generation EV charging infrastructure begin with purpose and passion. Thank you.
Thank you very much, sir, for your work planning over the coming days. I now invite Dr. R. Madana, Assistant Professor, to present the guest introduction.
A very good morning to all respected dignitaries, faculty members and dear participants. It is my great privilege to introduce our esteemed guest speaker for today's session, Dr. K. Mala. We welcome you, ma'am. Dr. K. Mala is a distinguished professional in the field of electrical engineering and renewable energy. She has earned a PhD in renewable energy from the prestigious Indian Institute of Technology, IIT Madras. She also holds an ME in Guindy in Anna University, an MBA in Human Resource Management from Annamalai University, and BE in Electrical Engineering from Madras University. With a rich professional experience of 23 years in teaching and 3 years in industry. She is currently serving as the lead engineer at Mahindra and Mahindra Limited, contributing her expertise to real-world industrial applications. Her academic and research excellence has recognized through several prestigious awards, including the Women Engineering Award by the Institution of Engineering and Technology, Chennai Local Network, the Lakshmi Krishna Iyengar Award from IIT Madras, and the Inertia Award for Innovation in Clean and Green Energy Technologies. She has made significant scholarly contributions with 45 international and 10 national journal and conference publications. She has also authored book chapters on DAY-1 Ocean Energy Systems published by NIOT Chennai, and her work has gained international recognition. She has guided for 4 PhD scholars and 15 ME projects and has presented her research at reputed international forums in Sweden and Spain. In addition, she has actively contributed to academia by organizing conferences, workshops and FTs. We are indeed honored to have such a knowledgeable and experienced expert with us today. We are confident that her session in our FDP will be highly insightful and inspiring for all the participants. Thank you.
Thank you. Now I request our distinguished chief guest, Dr. K. Mola, to share few words to the board.
Respected Advisor, Honorable HOD, Coordinator, all organizing team, faculty members from various institutions, faculty of SA Engineering College, my dear students. A very good morning to one and all. Good morning. It's my honor and privilege to be a chief guest for this FCP program. My sincere thanks to the management, advisor, principal, organizing team, coordinator of this program, Dr. Kamalakanan, who is my friend, for giving me this valuable opportunity. Thank you, Madana, for giving me a brief introduction. She had some 4 pages. I actually shortcutted all the things and sent, but I was surprised how come it is 4 pages. First of all, why this FPP? I was informed by Dr. Kamalakanan, 99 participants, 99 faculty applied for this program and 50 are shortlisted based on some criteria. Just I wanted to know which is inspiring you to apply for this FPP. Apart from MBA, NAC giving marks for 1 week, 2 week FPP programs, apart from that, what are the criteria inspiring you? Apart from performance appraisal by the management, which is inspiring you? AI, EV. Great. These kind of faculty development programs are most essential for nurturing our knowledge to have academic excellence. Because in today's rapidly changing educational environment, it is essential to upgrade our skills to meet the changing needs of the students, institutions and society. So, this FDP serves as the platform for knowledge sharing, skill enhancement and academic enrichment. Now, the role of teachers are continuously changing. Beyond teaching, you are expected to do research, innovation, mentorship and institutional development. How can a teacher do all these things? By following pedagogical perspective, digital tools and outcome-based approaches, you could achieve all this. My sincere thanks to the management, advisor, principal for organizing this kind of program. Their guidance and support make the organizing team to achieve all this excellence. I encourage all participants here to make the most of this opportunity by actively participating in all sessions, interacting with the resource persons and implementing the insights gained in this FTP and apply to the knowledge transfer among the students. I congratulate SA Engineering College for organizing this impactful faculty development program.
Okay, wow. சொல்லிட்டு ஒரு அடி பின்னாடி சொல்லுங்க.
And I am confident that this program will contribute significantly to enhancing the teaching quality and academic excellence. Thank you, and I wish you all success for this program. Thanks a lot.
Thank you so much, madam.
கிளியராக வேணும்ல ஃபேஸு. ஓகே சார்.
Have a quick introduction, just a name from college from which you are coming, okay? You could comfortably sit.
ஏங்க மேம்
I think that the girls can start up with that. Meena from SRM Kattanam. Meena from SRM Kattanam. SRM Kattanam.
Department of Line Engineering, Deputy.
Clear, madam? Okay. You could confidently, loudly speak, no? It's a forum for you, for networking. Feel free. Thank you. Shall I know how many of you have attended some courses in NPTEL or FDP or EB? You have attended both. What course you have attended? Okay. Yours? Somebody else also attended, right? Okay. Okay, let us start. Please feel free to stop me in case you have any questions. Am I audible to all?
லைட்டு போடலாம் லைட்டு போடலாம்.
My topic of presentation is electric vehicle architecture and its dynamics. This is the outline. We are going to discuss the overview, significance of such systems, design spec of EV motors, battery, BMS, cooling system, regenerative braking, some basics of EV dynamics, power and energy requirement for drivetrain design. We all know what EV is. It's a vehicle that uses electrical energy stored in a battery to drive the wheels. If we compare the conventional vehicle and EV, how we make the comparison? Finally, which is driving the wheel? In case of IC engine, it is the engine which is driving the wheel through the gearbox. In EV, it is a motor which is driving the wheels. Motor is getting power from battery. Okay, battery rating is approximately 300 to 800 volt. The inverter which is converting DC to AC in order to supply to the AC motor. In between motor and wheels, there is a speed reduction gear. Mostly in EV, a single gear is used, not like multiple gears in ICE vehicle. Types of EVs: hybrid electric vehicle, plug-in hybrid electric vehicle, battery electric vehicle, fuel cell electric vehicle. Let us see the comparison. In battery electric vehicle, the source is the lithium-ion battery. Charging method, it could be both AC as well as DC charging. What is the energy flow from power grid? The battery is getting charged. Battery is connected to the motor through the inverter. As discussed, battery stores energy in DC form. The DC is converted into AC in the inverter, which is driving the motor. Motor is connected to the wheels. What are the examples? Tesla Model 3, Tata Nexon. Next is the hybrid electric vehicle. Okay, what are the components present in hybrid? It's an engine and a small battery. In case of HEV, no external charging, only regenerative braking is used. So what is the engine flow? Engine combined with the motor through transmission supplying power to the wheels. Example, Toyota Prius. Next is the plug-in hybrid electric vehicle, PHEV. Engine is larger battery. How it is getting charging? Through external plug as well as regenerative braking. So energy flow is battery or engine to the motor and wheels. Volvo. Next is FCEV, fuel cell electric vehicle. The source is the hydrogen fuel cell. What is the charging method? Hydrogen refueling. From hydrogen tank, fuel cell stack, motor and wheels. Toyota Mirai is an example for this FCEV. So what are the major components and subsystems of electric vehicles? Electric motor for propelling the vehicle, motor controller or inverter with a closed loop feedback system, battery pack with battery management system with CAN communication system. CAN stands for Controller Area Network, we all know. A DC-DC converter for other peripherals. Apart from motor, we have many electric loops in EV, lights, etc. etc. Okay. For supplying that, we need a DC converter. Those are 12 volt systems. For that, we need a DC-DC converter. A vehicle control unit or master control unit for vehicle management and safety. Next is what are the charging infrastructure, on-board charger and it could be an external charger. Isolation circuits for vehicle and user safety and safety systems. EV subsystems, as discussed, energy storage system consisting of battery pack, battery management system, HV junction box, and thermal management for battery. Power electronics, inverter, DC-DC converter, onboard charger and motor controller. Next is the electric motor and drivetrain. Okay. What are the commonly used motors in EV? PMSM, SRM, BLDC or induction motor, permanent magnet synchronous motor, switched reluctance motor, brushless DC motor or induction motor. These are the commonly used motors in EV. As discussed, it is a single speed transmission, that is only one reduction gear between the motor and the wheel. How many differentials are used here? You all know the differential, right? In the automobile buses, differential. The purpose of differential is to making turn, the outer wheel makes little extra distance when compared to inner wheel. So this gives the differential car to both the wheels of the vehicle. So this differential could be a front wheel differential, rear wheel differential or all wheel differential. A thermal management system, battery cooling, motor cooling and cabin HVAC. What does HVAC stands for here? Heating, ventilation and air conditioning. Charging system, AC charging type 1, type 2 because it is a slow charging and DC fast charging. What are the protocols used? CCS2, charge mode, GB. What is the control and the communication network? Vehicle control unit. There is a controller in the battery called the battery management system. Motor control unit, MCU, and CAN, link, Ethernet. These are the communication protocols. CAN, link, and Ethernet. So what does EV drivetrain consist of? Battery, inverter, motor, and wheels. Battery provides DC voltage. BMS monitors state of charge, state of health, temperature of the battery, and current from the battery. The inverter that converts DC into AC. EV motors need three-phase AC. Inverter uses IGBTs or silicon carbide based switches. It controls motor torque and speed. As we know, the motor converts electrical energy into mechanical torque. When the AC current flows into the motor, a rotating magnetic field is produced, which is contributing to the torque on the rotor. PMSM is the most efficient motor used in EV. Motor drives the wheel. Single speed reduction gearboxes used between the motor and the wheel. No clutch, no gears, no vibration. Traction battery. It is the main energy source of the EV. It consists of lithium ion pack. Operating voltage is approximately 300 to 800 volt. So how it works? It stores electrical energy in chemical form, battery. It delivers DC power to the inverter and auxiliary systems of electric vehicle. It supports regenerative braking. It determines the range, performance and charging speed. The range of the vehicle performance and the charging speed is mainly determined by battery and battery management system. It supplies a stable voltage and current for all driving conditions. It is the largest and the most expensive component of EV. It directly affects the range. It requires efficient thermal management system to avoid thermal runaway, to maintain battery health and prevent the degradation. What are the power electronics component present in EV? Inverter, DC-DC converter. It converts and controls energy flow. Inverter converting DC to AC. DC-DC for the other load applications. Inverter drives the motor by controlling the three-phase AC signals. The DC-DC powers the 12-volt systems like lights, infotainment and LCDs. It acts as the electronic gearbox of the EV because there is no gear except the speed reduction gear. So this inverter and motor control unit acts as the electronic gearbox of the EV. It controls torque, speed and direction of motor. It directly impacts the efficiency, acceleration and range of the vehicle. The silicon carbide device improves efficiency and reduces heat. It must handle very high currents and needs strong cooling and proper insulation. Electric motor converts electrical energy into mechanical torque. Commonly used motors is PMSM, induction BLDC SRM. The inverter supplies power to the motor. The rotating magnetic field causes the rotor to spin. What is the role? This is the part which is providing the propulsion to the wheels. It enables regenerative braking. The acceleration, efficiency and the top speed of the vehicle are determined by the motor. It can provide high torque even at 0 RPM. PMSM motors are the most common due to the high efficiency of it. So based on the location of the motor in electric vehicle. These are classified as a single motor front wheel drive, single motor front wheel drive, single motor rear wheel drive, dual motor all wheel drive, in-wheel motors, that is hub motors, e-axle architecture. What are the differences? In single motor front wheel drive, only one motor at the front axle. The next single motor rear wheel drive, one motor at the rear axle. In case of a dual motor, one motor in front axle, one in the rear axle. What is the e-axle architecture? Motor plus inverter plus gearbox integrated into one unit, which is the e-axle. Key features, advantages are listed. In hub motors, the control is very precise, no gearbox, and it is modular design. Applications and examples are given. These are the motors. When we compare the motors used in EV, how to select the motor among the varieties available? When we compare the rotor type in PMSM, as the name indicates, it is the permanent magnet motor. In induction motor, it is the aluminum or copper cage rotor. Rotor is the squirrel cage type. In SRM, a laminated steel, no magnets, no windings. When we compare the efficiency, very high in case of PMSM, 95 to 98%. Moderately high in case of induction motor, 90 to 94%. And it is only moderate in SRM. When we compare the efficiency, PMSM gives higher efficiency. Torque, excellent low speed torque in PMSM, good high speed torque in induction motor, and high torque recoil percent in case of SRM. Noise comparison, very low in PMSM, low in induction motor, and it is high acoustic noise in case of SRM. What are the key advantages? Highest efficiency and performance in PMSM. Robust in construction, no magnet in case of induction motor. Simple, cheap and temperature tolerant in case of SR. What are the limitations? We have to look at the limitations. Cost of magnet and heat limits in case of PMSM. Slightly lower efficiency in case of induction motor. Noise plus the complex control in case of SRM. So PMSM, we compare the advantages and the limitation. PMSM is the most widely used. How to design the spec of the motor to meet the requirement of the EV? Finally, it is the motor which is driving the wheel. So how to decide the spec? What are the motor spec to be derived? It is the torque speed characteristics. When we say about torque and the speed, it is both nominal torque as well as the speed and peak torque speed. Okay, this specification to be defined. Power, nominal power and peak power for some 10 to 15 seconds. As long as there is no problem of temperature, we could go for peak power. This is the important spec of the motor, deciding the torque speed curve, both nominal as well as the peak values. So what is the structure of the battery from cell to module and then pack? We all know it. Cell is the basic unit, small unit of the battery. Approximately the voltage range is 3.2 to 3.7 volt. Okay, module is a group of cells. In a module, it is fitted with temperature sensors, mechanical casing, It ensures uniform temperature and structural strength. Okay. Group of modules consists of a pack. It contains BMS, cooling system, high voltage junction box, fuses and contactors. It provides the full medium voltage to the system. Safely delivers power to the inverter and the interior EV. What are the key takeaways from this? The pack is the complete energy system consisting of your modules and the cells or as building blocks. It is optimized for safety, serviceability and thermal performance. What is the battery power and range required? Both power as well as range are important, right? When we plan a travel, we have to reach the destination, which is defined by the range of the vehicle. So power during acceleration is determined by the battery power. As we know, energy is the integral component of power over time, or it could be a power over a driving force. Integral PDT or PDS here assess the distance. So, which are the parameters requiring high power? Gradients result into higher power and energy usage. And when we design the power requirement of the battery, what are the factors to be considered? Okay, it's only the range requirement, it is only the peak power requirement for the acceleration. So what are the factors to be considered? We have to consider gradient and other nature of the road. Inefficiency of the components, mainly motor, controllers, that need to be taken into consideration while designing. Approximately the losses due to inefficiencies may be between 10 to 20%. And energy efficiency at the lower speeds may be still lower. What are the auxiliary power requirement for light, infotainment and other loads? So what will be the total power taken by the system? The power used is equal to power taken by the motor, the losses due to inefficiencies, that is loss in the motor due to inefficiency, loss in the controller due to the inefficiency, and the power supplied to the auxiliary system. The addition of all these contribute to the power used. So what is the main takeaway? So battery to be designed to provide sufficient energy over the range as well as the peak power. So during design we have to consider all these factors. Next is the battery energy. How it is defined in terms of kWh, kilowatt hour, which is nothing but volt ampere hour divided by 1000. For long life of the rechargeable battery, we have to concentrate on the charging as well as discharging. It should not be fully empty and it should not be fully charged as well. So what is the usable energy for each charge and discharge cycle of the battery? If we define this as the X percentage, 85% of the total capacity. How do we say it is 85% of the total capacity? That is the usable energy of the battery. What is the meaning of usable energy? Because in a battery, for each charge and discharge cycle, we are not fully charging. Okay, there is some gap left at the top. We are not fully charging. And during discharging, we are not fully discharging. So, although there is the rating of the battery, how much we could use? Only 85% of the full capacity we can use. Okay, so let us assume it is 85% of the total capacity of the battery. Next, the capacity of the battery reduces for the each charge and discharge cycle. Okay. So when the battery capacity remains is, for example, some 80% of the initial capacity. Okay. The range gets proportionally proportionately reduced. Okay, so what is the cycle life? That is the usable capacity. At the end of cycle life, what is the usable capacity of the battery? If C is the actual capacity of the battery, in this case, if C is the actual capacity of the battery, anyway, when it is new also, we cannot use it for more than 85%. Okay, over a period when it is starts degrading, so we could use only, if the remaining capacity is 80%, we could use 80%, that is 0.8. Okay, so what is the usable capacity of the battery at the end of the cycle life? It is 0.8 to actual capacity of the battery. So it is approximately 0.6 into actual capacity of the battery. So we have to change the battery. We could use this battery for the secondary purposes. So, although the battery is having sufficient energy, the rate at which the power can be taken out, that is the discharge rate is very limited. Okay, because higher discharge rate impact the life cycle of the battery. Higher charging rate also impact the life cycle of the battery. What is the reason? Higher rate of charging and discharging heats up the battery. So, battery has to be designed to have peak power capability that the vehicle requires. It is dependent on the size of the battery and the nature of the cells used in the battery. The commonly used cells LFP and NMC. LFP stands for lithium iron phosphate and NMC nickel manganese cobalt. These are the materials used for cells. What are the auxiliary loads available so that the DC-DC converter could supply? Vehicle control unit, all lights, headlight, tail light, flashlights, motors for bypass windows, entertainment and guidance, other electronics, sensors. Let's see the battery management system. It's an electronic system that monitors and protects the battery, BMS. So, what does it measure? It measures the voltage, current, and the temperature of every cell. Balances cells for uniform charging. There are two methods, active and passive balancing techniques. It predicts the state of charge of the battery and state of health. It ensures the battery management system ensures safe charging and discharging, which prevents overheating, overcurrent and short circuits. This battery management system plays an important role in extending the battery life. Enables accurate range estimation. BMS decides power limits, that is reduced acceleration when battery is hot or low. What is EVCS? Electric Vehicle Charging System. Connects electric vehicle to external AC or DC charging sources. In case of AC charging, there is an onboard charger in the vehicle that converts AC into DC. In case of DC fast charging, the DC power source is directly charging the battery via external charger. The different communication protocols are CCS, CHAdeMO, GB/G. What is the role of EVCS? It allows slow, fast charging and rapid charging. It protects the battery during the charging process. Determines convenience, charging speed and infrastructure capability. The charging rate is limited by the battery temperature and SOH, health of the battery, which is controlled by the BMS. Why cooling system is critical in case of a battery. Battery temperature should be in optimal temperature range, that is between 20 to 40 degrees centigrade, to ensure safety, long life and performance. Why cooling is critical? To prevent thermal runaway, to increase the cycle life of the battery. It allows fast charging, maintains range in hot and cold climates. So what is the inference? In case of good thermal management, better safety, performance and cycle life. This is the conception view of battery cooling system. Battery assembly, adhesives, conductive coating, impregnation services, liquid gasketing, thermal gap filler and thermal adhesives. What are the types of cooling? Air cooling, liquid cooling, cold plate cooling, refrigerant direct cooling. From the slide, can you tell what is the difference between the liquid cooling and the cold plate cooling? From the figure, can you identify and somebody let us know what is the difference between the liquid cooling and the cold plate cooling? The name directly gives the meaning, right? Air cooling uses fan and ambient temperature. And it is a simple system and the cost is also very low. Used in older EVs and small scooters kind of things. Air cooling, right? Liquid cooling, the coolant used is, as we all know, it is a glycol plus water that is used as a cooling agent in case of liquid cooling. Glycol coolant removes heat from modules and it is of high efficiency, used in cars and high power EVs. Okay, so this is about the liquid cooling, which is the most common, with the glycol plus water as the cooling agent, providing high efficiency. Then what is the need of cold plate cooling? Can you see the thermal image here? What is your understanding about this thermal image? This is the schematic. This is the temperature distribution. The scale indicates this color, the red is having highest temperature range. So in case of this liquid cooling, the area which is exposed to the coolant, if you see the area around this coolant region, you could find a little lower temperature when compared to the other side of the cell. Okay. So there may not be uniform cooling in case of the liquid cooling. Although we say it is of highly efficient, there may not be uniform cooling. So when we go for a cold plate cooling like this, the battery modules sit on the cold plate made of aluminum. So it provides uniform cooling. This is the advantage when compared to liquid cooling. Next is the refrigerant direct cooling, which is the advanced method. AC refrigerant directly cools the battery cells. Used in high performance EVs and supports ultra fast charging because it is the temperature of the battery which is limiting the charging and the discharging. Next, how the motor is getting cooled. What is the method used for motor cooling? First, what is the cause of generating heat in the motor? The losses, copper loss, iron loss, and the friction is contributing to the temperature rise. A liquid cooling jacket around the motor removes this heat to keep the temperature within the safe limit. The coolant absorbs the heat and flows to the radiator or chiller where it is getting cooled and recirculated. Proper cooling ensures high efficiency of the motor, prevents the demagnetization of magnets and avoids power leakage. Next is inverter cooling, which is the cause for inverter getting heat. because the inverter is made up of several power electronic switches which are getting switched on and off frequently, which is the cause for the major cause for the heating of inverter. A dedicated liquid cooling plate or cold plate is attached to the inverter to remove the heat. The coolant transfer the heat to the radiator, or it could be a shared thermal loop with the battery or motor. Effective cooling maintains the switching efficiency, protects the electronics in the inverter and prevents thermal shutdown of the inverter. Next, let us see how the power flows in areas during acceleration, during cruise control and regenerative braking. Any of you have the idea of cruise control of the vehicle? Yes, maintaining a constant speed limit. That is the option to have a cruise control. If you are going on highways, you want to maintain certain speed. You want to give leisure to your rest to your legs. You could update the cruise control. How the power flows during acceleration of the vehicle? Certainly from battery and then inverter, motor, reduction gear and to the wheels. When the driver presses the accelerator, the torque demand of the vehicle increases. The battery provides DC power, inverter converts DC to AC and the motor generates high torque instantly. As mentioned, it can provide highest torque even at 0 amp. That is the major advantages of EV. So what are the key takeaways? Maximum current drawn during acceleration. Current requirement is very high for acceleration. And the flat torque even at low speeds, so it is a strong launch in case of EV. Thermal load is the highest. Why? High current. So thermal load in case is very high during acceleration. So power flow during cruising. This is a stable power demand. Vehicle runs at constant speed. Low to medium power drawn from the battery because there is no acceleration, deceleration, constant speed. So power requirement is low to medium. The inverter controls motor torque efficiently. Okay. Key takeaways: energy consumption is minimum. Efficiency is highest, 90 to 95% in case of a cruise control. Thermal system keeps component cool because it is not a high current requirement. As we all know, the next is the regenerative braking. So what are the regenerative braking conditions? When we slow down the vehicle, when we slow down, the electric motor reverses its functions and it acts like a generator. The spinning wheels force the motor to rotate, which converts the vehicle motion, the kinetic energy, into electricity. The inverter sends this electricity, it's a bidirectional inverter. This sends the electricity back to the battery for storage. Also, this reduces the load on the mechanical brakes. So the wear of the braking system is also reduced due to this regenerative braking. So from wheels, what is the power from wheels? Generator, the motor which is acting as a generator now, inverter and to the battery. How much energy that could be recovered using this regenerative braking? Almost 10 to 25% energy to be recovered in this regenerative braking. How much pedal wear is reduced? 60 to 90%. Great. BMS limits regen at low temperature or at high viscosity. So this is the limitation. Although it would give 10 to 25% of the energy, the battery temperature and the state of charge of the battery decides how much power that could be stored in the battery. So when we proceed into vehicle dynamics, let us see first some basics about the vehicle dynamics. Okay, when we talk about the dynamics, what are the criteria, what are the areas the dynamics to be taken care. The first is the acceleration dynamics. EVs gives instant torque, no gears, no lag, power reduces at high speed due to motor dynamics. So what are the key benefits? Quick launch, smooth acceleration, no shift or shock. What are the dynamics to be considered during braking? Regenerative braking converts motion into electrical energy. Blended braking mixes regen plus mechanical braking. Advantages: increased range, because what is the efficiency of the regenerative braking? How much power we are getting back? 10 to 25%, which is contributing to increase in range. Increased range, reduced brake wear and smoother stops. Yes. No. So when regenerative braking is happening, when you apply the brake or when you slow down the vehicle, okay? When there is the necessity of suddenly dropping the vehicle, suddenly stopping the vehicle, you press the brake. Otherwise, when you slow down, the motor reverses its function, it acts as the generator. So frequent pressing of braking is also not necessary.
Second. அவன் ஃப்ரெண்டி போடா
Yeah. When you compare the energy of the battery for a specific drive, okay, what is the energy required to complete that drive? What is the regenerative braking happening during that drive? When we compare, what is the energy spent? How much energy could be recovered using regenerative braking? Then comparison. Overall, during that journey, how much is the recovered energy due to the regenerative braking? That is what the literature says. Next is the traction and stability dynamics. The motors can control torque for each wheel. It helps on hills and slippery roads. So superior grip, torque vectoring, strong hill start performance. These are the key benefits during dynamic control of traction and stability. Thermodynamics, battery, motor and inverter are producing heat. Therefore, the cooling system manages the temperature, it maintains the performance, protects components and ensures the safety. So what we are going to discuss in this vehicle dynamics? We are going to discuss about energy dynamics of the EV. So what are the points we are going to discuss in this? We are going to talk about the traction, load transfer, rolling resistance, aerodynamics. Few of this terminology you may already know. So what is the traction? There is a grip between tires and road. Traction is the ability of the tires to transfer the motor torque to the road without slipping. EVs have high instant torque, so traction control is very, very important. All-wheel drive EVs improve the traction by controlling the torque to each motor and wheel. When compared to front wheel and rear wheel drive, all-wheel drive improves the traction control. So next is the load transfer. When EV is accelerating, how the weight is shifted? Weight shifts to the rear axle, rear tires. So better get traction when braking, the weight shift to the front axle. So during cornering, that is turning, weight shift to the outer tires. So these are the dynamics associated during load transfer. So low battery placement reduces load transfer, improving the stability and handling. Next is about the rolling resistance. It's nothing about a tire friction with the road. rolling resistance. It is the energy required to keep tires rolling on the road. Lower the rolling resistance, better is the EV range. What are the contributing factors for this rolling resistance? This is the tire material, tire pressure, road roughness and vehicle weight. EVs use low rolling resistance tires to maximize the driving range. Low is the rolling resistance, high is the driving range. Next is about the aerodynamics. What is air drag? Aerodynamic drag increases with speed, especially above 60 km per hour. EVs are designed with smooth surfaces, closed grills and optimized shapes to reduce this aerodynamic drag. What is the comparison between drag and the range? Lower the drag, higher is the range. So what are the forces acting on the vehicle which is in motion? In the picture you could understand how the aerodynamic drag acting on the vehicle which is in motion. The forces acting on the vehicle are, one is the aerodynamic drag, which is opposite to the vehicle in motion. Rolling resistance due to roughness and other things of the road. Uphill resistance, acceleration. These are the forces acting on the road. What's the equation for the aerodynamic drag? What are the parameters contributing to the aerodynamic drag, which is opposite to the vehicle in the motion? It is half rho CD A V square. Rho is nothing but the air density at a temperature of 27 degrees centigrade. The air density is 1.2 kg per meter cube. CD is the drag coefficient. A is the vehicle frontal area, meter square. And V is the velocity in meter per second. So what is the relation between the drag and the velocity of the vehicle? The drag is proportional to square of velocity. Rolling resistance mg mu cos theta. How to determine this rolling resistance? If the permissible load of the vehicle is m kg, the weight acting is m into g. M into g. Mu is the rolling coefficient. So rolling resistance is mg mu into cos theta. What is the uphill resistance of the climbing force, which is mg sin theta? And these are evitable from this diagram. So what is the maximum grade? The grade in percentage, grade or inclination. The grade angle is theta. In terms of percentage, we could express grade as height of the grade divided by base of the grade, that is P divided by D. How to find the grade angle? It is tan inverse P by D. So what is the tractive force? This tractive force created by the powertrain first to overcome all these resistances. Aerodynamic drag, rolling resistance, uphill resistance, it has to overcome all these resistances and then it provides the acceleration. If we express the tractive power required by the vehicle as speed track, which is in watts, then how to express this speed tractive power in terms of the equation? It's the power which is force into velocity. Tractive force into velocity of the vehicle in meter per second. What is the resulting torque on the vehicle wheel? Torque is equal to tractive force multiplied by radius of the wheel. As mentioned, Acceleration will be provided only after overcoming all the resistances due to this aerodynamic drag, rolling resistance and the climbing force. So what is the total tractive force required? Force required to accelerate the vehicle, force required to overcome the drag, aerodynamic drag, rolling resistance and the climbing force. What about the energy? It is the integral part of tractive power over a time, or it is the integral part of tractive power over a distance. So, if we consider the regeneration efficiency here, regeneration efficiency is denoted by capital R. So, if the regeneration factor, if we take as approximately 15 to 30%. Approximately, if we take this as 15 to 30%, then it is typically, the regeneration factor is typically in terms of percentage 0.85 to 0.7. So how to design the drivetrain? Drivetrain is designed to provide adequate force and torque at different speeds to overcome all these parameters and provide the right acceleration. That is the pickup. Adequate power and speeds for different kinds of drives of the vehicle. What is a drive cycle? It's nothing about the concept of energy efficiency of the vehicle in terms of whatever per kilometer. It depends on how the vehicle travels, how much energy it takes to complete the travel. As we know, the energy required will depend on the speed, acceleration, idling and deceleration. So how to define a drive cycle? A definition of drive cycle is how the vehicle is typically driven. That defines the drive cycle. So how the vehicles are tested? Vehicles are tested as per the standard drive cycle. That is how long it travels, at what speed it travels, how it is accelerated and decelerated. What's the meaning of standard drive cycle? Why it is standardized? A drive cycle is standardized so that different vehicles can be tested over that standard drive cycle and it could be compared. Each vehicle, that is either it is a two-wheeler, small car or bus, may have its own drive cycle. So the drive cycle depends on the vehicle. It depends on the location, the city, town in which it is being tested. A fuel-current drive cycle should include its own drive cycle. So as we know, it depends on the location. Different countries have different drive cycles. So to sum up, what is the torque and the power requirement for the vehicle? It is largely driven up by the pickup time, that is the time to acceleration, because acceleration requires high torque. If it is a slope, it still requires higher torque. Torque and power requirement will be high for higher speed, although no significant effect for speeds up to 60 kph. If it is exceeding 130 km per hour, larger power is required. We all know power is proportional to cube of the velocity of the vehicle. Besides torque and power, vehicle speed is also a major parameter. Right gear is sure to be chosen to optimize this torque and speed, although it is having a single reduction gear. So what is the energy requirement while designing the electric vehicle? While calculating the energy requirement, we have to consider the inefficiency of the motor and the controllers. Auxiliary power and energy requirements should also be compared. Shall we go for the case study? We could read this. And electric vehicles having inconsistent regenerative performance in cold weather. And also at high battery SOC. What are the vehicle dynamics involved in this? You could take over and give some inputs. What are the dynamics involved in this? Inconsistence in regenerative braking due to cold weather and high battery SOC. What are the dynamics involved in this case?
Okay.
Yeah, because of cold weather, temperature of what is deciding the dynamics. Because it is the regenerative braking, motor is acting as a generator which is providing power to the battery. So which temperature is the contributing factor? Battery temperature. And in cold weather, the temperature of the battery is very low. For optimal charging and discharging, it is better if the temperature of the battery is 20 to 40 degrees centigrade. Okay, any other contributing factors? Resistance of okay. Torque control. Okay. The regenerative braking torque control is the dynamic involved. Charging limits of the battery during the cold condition, and it is also at a higher rate of charging. Now battery is at a higher SOC, and motor is acting as the generator and it is providing the power. So they should have a torque control over the battery, because there is the limitation. Cold weather I can't do recharging because the temperature limit of the battery should be in the optimum range. It is already almost reaching its higher capacity. Torque control is important. Thermal dynamics of the battery and both motor, back EMF and the inverter controls. These are the contributing dynamic factors during regenerative braking. EV is facing power drop on steep hills under hot weather. The dynamics involved. High gradient resistance. Okay. Because of the steep hills. Hot weather, so that's the thermal dynamics involved. Thermal dynamics involved for all the components, of course, battery, inverter, and motor. So this is the grade of the road which is contributing because it is the steep hill. Hot weather is the important factor. So what are the dynamics involved? The battery temperature is not only battery, inverter, motor. The power limits based on the cell temperature. Yes, of course. When it is at higher temperature, the charging is not taking place, right? So continuous torque demand in this case because it is uplifted. So there is the continuous torque. This is also there. It's a front wheel drive, but provides instant torque. What are the vehicle dynamics involved? Traction control because the weight is shifting during the acceleration, braking, cornering. It is a front wheel drive. Therefore, the traction control is most important. Okay. And the motor is fitted in the front axle. We should have a slip control of all four vehicles. Motor speed torque dynamics. Single motor in front axle. As mentioned, there is a drags, weight transfer, flow transform. So better speed task control should be there to have a control over the vehicle. You compare yourself driving the two-wheeler. Okay? When it is in back axle, the control is, it is pushing the front. But when the source is at the front wheel, the control bracket is high because it is directly right. So which is providing the control? It is the motor control, the torque control, the speed control. So it should be having these dynamics to be kept in mind while designing the software about the control, speed control. Now everything is software. Almost 85 ECUs are available in HCD assembly. So all these dynamics to be taken care while designing the spec, while writing the software for controlling the torque, speed, etc. It's only about what are the different dynamics. It's nothing but only thing is it is the instant torque at 0 RPM, right? That is the matter. Although it is under the rear wheel drive, the impact is less when compared to the control to be taken extra care if it doesn't at the wheel. Yeah. And now it is all-wheel drive. All-wheel drive. Then the capacity is higher. It's better to go for all-wheel drive for better control, stability. Of course, there should be an optimism. As I mentioned, it is for a higher capacity vehicles. Better to go for all-wheel. When the size of the vehicle increases, the worry about the size of the battery is reduces. To sum up, electric vehicles need to have motor and the controller to drive the vehicle as per the drivetrain requirement and the car requirement. But with sufficient energy as well as sufficient power, both are essential. What are the EV dynamics involved? We have seen the vehicle energy dynamics based on the power, energy and the torque demand. The impact of various parameters like aerodynamic drag, rolling resistance, uphill resistance, vehicle frontal area, vehicle acceleration, regeneration, all these forms are discussed. That's all. This is from my end. Any queries? Thank you so much. Yes, please, Pastor. That's the C rate for charging and discharging. Okay? Fast charging, it is the convenience. How long we could wait during an intermediate travel. Definitely, of course, we have to go for fast charging. Yeah, that is having some impact on the exit of the battery, but it is inevitable. Yes.
So that means that the components in the range. If we say 300, we can have only 88% of 300.
During design itself, it is taken care. 85% is the usable capacity of the battery with definite depth of discharge. Okay. So while designing the EV itself, it needs to be taken care. If we say battery of this much PAH, we have to do the design calculation. If it is of this much capacity, what will be the range provided? Finally, when we talk about the range, it is defined. EV of this type, for example, Mahindra P9060, it will provide 100 km range. So that is the objective. The range is the objective. For that range, what is the spec of the motor? What is the spec of the battery? That has to be defined. It is not about deciding the range and then calculating the motor battery designing. So while designing itself, this much we decide, this much battery capacity could give 500 km range.
And the kilometers with 80%.
Yes, 85% means, please understand, while designing the battery, for example, if we say some 1000 ampere hour, okay, so while designing that itself, we have to decide all the things. If this is the battery, what are the load requirements? I am going to supply the electric motor of this much spec. It is taking a power of this much kilowatt. So in order to have a specific range, what is the battery requirement? Okay. So if I require 100 ampere hour battery, I cannot make it fully utilized. So because it could usable capacity is only 80%. So I have to change the battery design accordingly. 100 ampere per hour is for 500 km. But to supply that and to consider inefficiencies and to supply light, other accessories, how much should I decide? It is not 100 ampere. It is only for 500 km range. By considering other factors, it will be 120, 130. Please compare about it. Definitely. There will be self-discharging of the battery. So, for that, there should be some periodic wake-up could be implemented so that this LV battery of 5 volt could be charged by the HV battery. As we know, there are two batteries, HV battery for supplying all this component, LV battery for lightning and other accessories. Okay. There should be a periodic wake-up to avoid this self-discharging. This ECU will wake up the LV system and estimate what is the current voltage. If it is not within the limit, it wakes up the HV system battery and it is charging. Definitely, both cold as well as hot drivers having the and also one more thing, we cannot charge the battery, recharge the battery at the cold temperature. For that, the thermal system should be kept. It has to heat the system and then only this minimum temperature should be reached.
Charging for 80%, again I'm discharging up to 20%, again charging.
Yes.
This will be coming under the one complete cycle, because from 0 to 100 there's a complete charging and complete discharging.
It is if you are charging 50% now, later if you are charging from 50 to 80, it completes 1 cycle. 1 cycle. 0 to 80. As we know, in our mobile itself, it is 6. I am very comfortable. If you take our mobile phone also, it is mentioned sometimes we forget to recharge now, it shows 0. Doesn't mean that it has gone. That is already the charge is protected. Okay, 0% means there is some charges there. 10 to 15% it is there in the battery. For the battery it is 10% charging. For the user it is 0%. All these protections will be taken care. So if you are charging to 100% means it doesn't mean that you are charging 100%. You are charging 85%. 100% for the user, 85% for the battery. Induction motors are used mostly in two-wheelers and the cheaper EVs. EMS is going for hospitals. Induction motor for mostly two-wheelers. BRDC induction motors. Four-wheelers also induction motors are used. It is based on the industry. It is based on other parameters. Yes. This is the advancement.
Maximum temperature in India, what was maximum temperature? He said 20 to 40 degrees Celsius you have to maintain. Okay, with the proper cooling system. Also, there is a problem with the cooling system. What can be the maximum
impact of
temperature?
It is based on the designer. If we decide for the given system, 20 to 40 degrees is the optimum range to be maintained. As I mentioned, there is the vehicle control unit, there is the BMS, which is continuously monitoring the voltage, current and temperature. Okay? If the temperature exceeds beyond the limit, automatically the charging system gets cut off during charging. Okay? During propulsion, that is the cooling system. That is the software which is constantly monitoring all this.
BMS system will not predict the temperature go beyond 40 degrees.
Yes.
So we suppose the BMS system is not there. So there is a problem with the BMS system.
Yeah, that is always a slab. Okay. 40 degrees centigrade means we say 20 to 40 degrees, plus or minus 10% will be maintained. Okay. In case there is the enough safety system which is monitoring all these things continuously in the system. Okay. If we want to, there is a continuous alert given to the user. So these are the suggestions. So restrict charging, restrict your driving. Automatically the cooling system will be taken care of. It will not start cooling at 40 degrees centigrade. If I want to maintain my battery at 40 degrees centigrade max, the cooling system will start its work even at the 30 to 33 degrees centigrade. It ensures it is not going beyond the bracket. That is the design to be taken. For the complete software, as I said, if I fix the maximum limit to 40 degrees centigrade, the cooling system will not start at 40 degrees. And also, the cooling system works for change in temperature pattern. Okay, so now it is 30 degrees centigrade. What is the temperature of the next instant? Either it is going to 34 or it is going to 30. Based on the trends of increasing or decreasing the temperature, there is the algorithm which plays the role there. Either increasing trend, okay? Switch on the cooling system. So it decides when the cooling system should be on and off, so that it is ensuring the temperature is still maintained. But it is not permitting to go beyond the maximum temperature. That is why cooling system is
on behalf of the department of...
I thought you were going to ask question.
Any questions? On behalf of the Department of Public and the Organizing Committee, I express my sincere and heartfelt gratitude to Dr. Mala, EDCO, Mahendra and Kushwali, Mahendra and Mahendra for delivering incredible and enriching sessions. Ma'am, your valuable time, expertise and practical perspectives have greatly benefited all the participants and we are truly thankful to you. Now I request our beloved HOD, Dr. Sindhu Master, to present this program platitudes. Thank you, sir.
Robert Henderson, Mrs. Aishwarya Kanacharian, Mrs. Dharmika, Ms. Dr. Dr. Deepthi Joseph. 5 members from team Robert Henderson. Team Robert Henderson. Mrs. Aishwarya, Mr. Dhananjali, Ms. Dharmika, Ms. Dharani, Mrs. Deepthi Joseph, Dr. Deepthi Joseph, to come to the site. Can I please let you guys know? Robert Henderson. The faculties are requested to come forward. Team 2, William Morrison, Dr. Dinesh Balasubramaniam, Mr. Hilal Bharati, Mrs. K. Gayatri, Dr. Geeta, Dr. G. Geeta Mahalashmi. The following faculties are requested to come forward. The names are being repeated. Team 2, William Morrison.
வீடியோ எடுத்துறியா ஃப்ரெண்டில் போயிருக்கிறேன் என்ன பண்ணுறேன் நான் போயிருக்கிறேன்
Here in the print is Vivo mobile phone with
மதியம் ஈஸி தானே
இல்லை ஃபுல் டே இங்கே தான்.
ஃபுல் டே இங்கே தான் அப்போ இருக்கட்டும் ஈவினிங் ஃபுல் டே இன்னைக்கு ஒரு நாள் இங்கே
நான் சொல்லுங்க சார். இங்கே தான் சார் இருக்கேன்.
அந்த கிஃப்ட்டு தட்டு கொடுக்குறதுக்கு வேணும் சரியா
ஆமாம் ஆமாம்.
நாளைக்கு நாங்கள்
comprehensive analytical study of EV dynamics and its essential parameters. Schematic diagram of the EV is mentioned, as we have seen in the presentation. Overview of hybridization are given by the how battery and supercapacitor can be used as a combined source. Similarly, what are the other sources that could be hybridized, like battery with alpha capacitor, battery with different hybridization discussed in the paper. Next, we have gone for EV dynamics. Okay, the basic power, energy, and the speed relations are discussed. Different equations for aerodynamic drag, for all dynamics, whatever we have discussed. Equations for drag, resistance, gradient are given. Next is the equation for vehicle acceleration, that is accelerating force, mass into acceleration. F is equal to M into acceleration, accelerating force is equal to mass into acceleration. And we discussed the combined acceleration. Next, a graph on force is given for different vehicles, starting from 2015 Nissan B4, Toyota Prius, etc. So the speed and vehicle road load force, the relation is discussed in that. Speed versus vehicle load force is discussed, as well as speed versus force and power. Those are the graphs given. Performance analysis of battery operated electric vehicle. Range versus speed. How the speed of the vehicle impacts the range covered. What is the power and rated load? For the different vehicles, the specification like battery, range, acceleration, weight of the vehicle, what happened? That's definitely give you fundamentals of all design calculations, comparison of vehicles. It is almost related to whatever the topics we have provided. It's good that we got surprised how whatever the content we have read, it has given us the database. All the best. Have a enchanting sessions for all 5 days. Make it useful. Have good interactions. Many questions. It's good that we have had active listening. And apply all these insights to your students. All the best for your academic excellence, research, innovation, applications, patent proposals. Thank you.
Representative from any team to come forward and share your key perspectives, insights and observations from the article discussion. Give my highlight the important key takeaways, critical analysis or any questions that emerged during the group discussion. Let's begin with I request anyone representative from any team.
So this paper is the counter-resist analytical study of directly vehicles dynamics and its social parameters. Our team, I'm basically from mechanical engineering. Anyway, okay, this paper is, this focuses mainly on the theoretical analysis using the simple mathematical model. This set of applications, as another rightly said, it is well discussed in the first session. So, as I said already, it focuses on electrical dynamics. It also explores various technical parameters which influences the performance, efficiency and the power. So there are such applications, and also they have given some introduction about the hybridization techniques, various techniques that are incorporated in the EVs. So it also analyzed the effect of vehicle speed on force, power and the range. If you see the effect is the vehicle speed directly proportional to force and power, and it's inversely proportional to range. That is the findings from the theoretical analysis. So this kind of analysis will lead to the final mathematical model to predict how to improve the safety, performance and the overall engineering specifications. That's all. That is what was our understanding. Thank you.
Any other representatives? Kindly speak for us, please. Anyone? Anyone from any team? For article discussion, please be providing a template where you can insert your key takeaways of the session, particular paper, article. So moving on, to complete the session. From the article, we infer that electric vehicle dynamics form the foundation for understanding EV performance, efficiency, and safety under real-world operating conditions. Aerodynamic drag, rolling resistance, and road load forces significantly influence energy consumption and driving range, especially at higher speeds. Accurate analytical modeling of vehicle forces and power equipments is essential for effective EV design, performance optimization, and control strategies. The use of hybrid energy storage system improve energy management, power delivery, and overall system reliability in electric vehicles. The study strongly supports the role of EV dynamics analysis in advancing sustainable mobility and guiding future research and industry applications. We will now have a breakdown lunch from 1 to 2. Lunch will be served at the canteen, which is located at left of Brooklyn Department entrance. I request the participants to kindly wait for the lunch hour. So I request the participants to kindly wait for 5 minutes. We will inform you. Thank you. For the afternoon session, there will be a venue change. It will be held at ECE ground floor, ECE seminar hall. Okay. ECE department ground floor. ECE seminar hall. The venue is ECE seminar hall for the afternoon session. I request the participants to kindly reassemble at 2 p.m. Thank you. Here in the front is Vivo mobile phone with
மதியம் ஈஸி தானே
இல்லை ஃபுல் டே இங்கே தான்
ஃபுல் டே இங்கே தான் அப்போ இருக்கட்டும் ஈவினிங் ஃபுல் டே இன்னைக்கு ஒரு நாள் இங்கே
சொல்லுங்க சார் இங்கே தான் சார் இருக்கேன் ஆமாம் ஆமாம்
It is a comprehensive analytical study of EV dynamics and its essential parameters. Schematic diagram of the EV is mentioned, as we have seen during the presentation. Overview of hybridization vehicles are given by the how battery and supercapacitor can be used as a combined source. Similarly, what are the other sources that could be hybridized, like battery with alpha capacitor, battery with hybrid, different hybridization discussed in the paper. Next, we have gone for EV dynamics. Again, the basic power, energy, and the speed relations are discussed. Different equations for aerodynamic drag, for all dynamics, whatever we have discussed. Equations for drag, resistance, gradient are given. Next is the equation for vehicle acceleration, that is accelerating force, mass into acceleration. F is equal to M into acceleration. Accelerating force is equal to mass into acceleration. And we discussed the combined acceleration. Next, a graph on force is given for different vehicles, starting from 2015 Nissan Leaf, Toyota Prius, etc. So the speed and vehicle road load force, the relation is discussed in that. Speed versus vehicle load force is discussed, as well as speed versus force and power. Those are the graphs given. Performance analysis of battery operated electric vehicle. Range versus speed. How the speed of the vehicle impacts the range covered. What is the power and rated load? For the different vehicles, the specification like battery, range, acceleration, weight of the vehicle, what number. It's definitely a good paper for starting EV study. Thank you, organizers, to arrange this kind of things. It will definitely give you fundamentals of all design calculations, comparison of vehicles. It is almost related to whatever the topics we have provided. It's good that we got surprised how whatever the content we have done, it has given us the paper. All the best. Have a enchanting sessions for all 5 days. Make it useful. Have good interactions. Many questions. It's good that we have had active listening. And apply all these insights to your students. All the best for your academic excellence, research, innovation, applications, patent, proposals. Thank you.
Representative from any team to come forward and share your key perspectives, insights and observations from the article discussion. You may highlight the important key takeaways, critical analysis or any questions that emerged during your group discussion. Let's begin with I request anyone representative from any team.
So this paper is the comprehensive analytical study of electric vehicles dynamics and its social parameters. Our team, I'm basically from mechanical engineering. Anyway, okay, this paper is, this focus is mainly on the theoretical analysis using the simple mathematical model. This set of applications, as Madam rightly said, it is well discussed in the first session. So, as I said already, the focuses on electrical dynamics. It also explores various critical parameters which influences the performance, efficiency and the power. So there are set of applications, and also they have given some introduction about the hybridization techniques, various techniques that are incorporated in the EVs. So it also analyzed the effect of vehicle speed on force, power and the range. If you see the effect is the vehicle speed directly proportional to force and power, and it's inversely proportional to the range. That is the findings from the theoretical analysis. So this kind of analysis will lead to the final mathematical model to predict the how to improve the safety, performance and the overall engineering specifications. That's all that is what was our understanding. Thank you.
Any other representatives? Kindly, please. Anyone? Anyone from any team? For article discussion, please be providing a template where you can insert your key takeaways of this session, particular paper, article. So moving on, to complete this session. From the article, we infer that electric vehicle dynamics form the foundation for understanding EV performance, efficiency, and safety under real-world operating conditions. Aerodynamic drag, rolling resistance, and road load forces significantly influence energy consumption and driving range, especially at higher speeds. Accurate analytical modeling of vehicle forces and power equipments is essential for effective EV design, performance optimization, and control strategies. The use of hybrid energy storage system improve energy management, power delivery, and overall system reliability in electric vehicles. The study strongly supports the role of EV dynamics analysis in advancing sustainable mobility and guiding future research and industry applications. We will now have a break for lunch from 1 to 2. Lunch will be served at the canteen, which is located at left of Brooklyn Department entrance. I request the participants to kindly wait for the lunch hour. It's been so I request the participants to kindly wait for 5 minutes. We will return you. Thank you. For the afternoon session, there will be a venue change. It will be held at ECE ground floor, ECE seminar hall. Okay. ECE department ground floor. ECE seminar hall. The venue is ECE seminar hall for the afternoon session. I request the participants to kindly reassemble at 2 p.m.